Hello everyone, welcome to Code Overdose. In this video, I'll show you how to implement a single sign-on system using Identity Server 7 on .NET 9, and how to set up authentication and role-based authorization in a Blazor Web App with Identity Server. I'll start with a quick demo to show how it works. As you can see, we have two Blazor applications, one Identity Server, and one secure API. Let's open Blazor 1. You'll notice it shows Not Authorized, and when it tries to call the secure API, it returns Unauthorized. Now, when I click Login, it redirects to Identity Server and displays the login page. We can log in using a username and password, or by signing in with a Google account. After logging in, we're redirected back to our app. You'll see the user's name, and content is displayed based on the user's roles. When this Blazor app calls the secure API, it returns data based on those roles. Next, let's open the Blazor 2 app. Before logging in, it also shows Not Authorized. When I click Login, it redirects to Identity Server, which immediately returns the login info to this app, since we already logged in earlier. The app gets the user's name, and if I refresh, it still works fine. Now let's switch to another account. Click Logout, then Log In again, and choose a different account with a different role. You'll see the name changes, the content updates, and the secure API now returns Forbidden. We can also log in using a Google account. Just click Log In with Google, choose your account, and click Continue to accept. The app retrieves the account name, but since there are no roles assigned, role-based content isn't displayed. That's it for the demo. Before we start building the solution, don't forget to subscribe for more content. And now, let's get started. Let's start with the basics. What exactly is Single Sign-On, or SSO? In simple terms, SSO allows users to log in once and gain access to multiple applications without having to log in again for each one. It centralizes the authentication process, so the user doesn't need to remember separate usernames and passwords for every service. This is incredibly useful in both enterprise environments and modern SaaS ecosystems, where a single user might interact with multiple apps that are part of the same system. From a user's perspective, it means a smoother, more convenient experience. Log in once, and you're good to go. From a developer or system admin perspective, SSO helps enforce consistent security policies, simplifies user management, and reduces the risk of password fatigue or weak credentials being reused. In this video, we'll implement SSO using Identity Server 7, an OpenID Connect and OAuth 2.1 compliant solution, and show how it integrates cleanly with multiple .NET 9 applications. Now let's take a closer look at how Identity Server 7 fits into the authentication flow, as shown in this diagram. On the left, we have the Identity Server, which acts as the central authentication authority. It's responsible for validating user credentials, issuing tokens, and managing access to protected resources. In the middle, we have Client 1 and Client 2. These represent two different applications, like a Blazor WebAssembly front-end and an MVC admin portal. These clients don't handle authentication themselves. Instead, they redirect the user to Identity Server when login is required. Once the user logs in successfully on Identity Server, the server issues an identity token and an access token back to the client application. These tokens can now be used to call the secure API on the right. The API validates the access token to determine if the user is authorized to access the requested resource. At the bottom, we have the database, which Identity Server uses to store user credentials, client configurations, tokens, and other identity-related data. So in summary, clients delegate authentication to Identity Server. Identity Server authenticates the user and issues tokens. Those tokens are used to securely access APIs. This architecture decouples identity from your apps, enforces a consistent security model, and enables single sign-on across your entire ecosystem. Now let's implement this. First, we need to install the Identity Server template. Search for Identity Server. You can see the website duendasoftware.com here. This is the official website of Identity Server. It includes everything about Identity Server. Go to the documentation and click Explore Docs. On the Quick Start overview, you can see the terminal command to install the template. Copy this, open the command prompt, and run it. It will install the entire template for Identity Server. Then go to Visual Studio, search for Identity Server, and you will see a lot of templates here. We will choose Identity Server with ASP.NET Core Identity. Set the project name as Identity Server and the solution name as Identity Server SSO. A web app will be created. It is basically an ASP.NET Core web app with Razor pages. Let's see what we have in this template. In the Data folder, we have migrations for the code-first approach and a DB context file using ASP.NET Core Identity. In Models, we have Application User. In the Pages folder, we have a lot of UI pages here, serving basic functions of Identity Server. Mainly, in the Account folder, we have Login and Logout UI pages, which we can customize if we want. In the Config file, it configures Identity Resources, API Scope, and Client. Identity Resources is a collection of identity claims that a client can request during authentication. These claims are sent in the ID token or from the user info endpoint. The API scopes in Identity Server are scopes used to protect the API. Each scope represents a specific set of permissions that a client can request when obtaining an access token. The client's collection in Identity Server defines which clients' applications are allowed to connect and how they can authenticate and request tokens. The M2M machine-to-machine client credentials flow is a method in OAuth 2.0 used to grant access between servers or services without direct user interaction. Interactive client using authorization code flow plus PKCE is a popular pattern in OAuth 2.0/OpenID Connect for authenticating users on applications with user interfaces UI, such as front-end web applications or mobile apps. In hosting extensions, it uses add DB context with use SQLite, then add Identity Server, and we also have add Google for Google Login. In the program file, we have configuration to seed data. Lastly, in seed data, the method ensure seed data will create example user accounts for identity. It creates an account named Alice with a password here, and another account is Bob with the same password. To run this Identity Server, we will create a SQLite database. Open the NuGet Package Console window, run Update Database. When it's done, we have the ASPID user DB file here. If you go to the program file, you can see the line that if the argument contains seed, the seed data function will be called. So to seed the data, we go to Launch Settings. Set the command line argument to seed. Rebuild it to apply changes for the Launch Settings file. Then run this app. You can see it is running. If it stops after a few seconds, the data is seeded. Then comment this line, then run this app. The Identity Server page appears now. Click the link to log in. Set the username to Alice and the password the same as in the seed data file. Then click Login. Great! We are logged in now. It shows all the claims of this account, and we can log out from this account. The Identity Server is working well. Now we will create the Blazor app to log in using this Identity Server. Let's add a new project. Search Blazor and pick the Blazor Web App. Name it Blazor 1 with Server Interactive Render Mode. Use .NET Aspire for orchestration and create. You can see we have a Blazor app, an app host, and a service defaults library. Then, create another Blazor Web App. Name it Blazor 2. Then add a web API. Name it Secure API. Next, we will configure the Identity Server. Go to the Program of App Host. Add a project reference to Identity Server. Then add Project to App Host. Then I will change the port of Blazor 1 to 6001, Blazor 2 to 6002, and Secure API to 6003. Then run the app host. You can see 4 projects running. Open to check that they are running OK. Next, let's implement the login function for the Blazor app. First, go to the config of Identity Server. Each Blazor app is an interactive client, so I will change client ID to Blazor 1. Then change the URL to 6001. It is the port of Blazor 1. Then copy to another one, with client ID as Blazor 2. Change to a different secret and set the port of Blazor 2. Configuring Identity Server is done. Now let's go to Blazor 1 in the program file. Open NuGet Package Manager. Search for OpenID Connect. Install the package Microsoft.NET Core Authentication OpenID Connect. Then add Authentication with options. Default scheme is Client 1 cookie. Default challenge scheme is OIDC. Then add cookie Client 1 cookie with the name Client 1 Auth. Then add OpenID Connect OIDC with options. Sign-in scheme is Client 1. Cookie authority is the URL of Identity Server. Client ID is Blazor 1. Client secret is the secret from the config file. Response type is code. Use PKC is true. Save tokens is true. Add scopes, OpenID, profile, scope 2. You can see in the config file we have a list of allowed scopes for Blazor 1. Then add cascading authentication state. Then use mapGet to define an API GET method. The path is /authentication/login. Then call context. Challenge async with the name OIDC, and authentication is done. Redirect to root. Then create another HTTP GET API for logout. It calls results.signout function with redirect to root and uses the names of default challenge scheme and default scheme. Then go to the main layout. Use the Authorize view tag. If authorized, show hello with the identity name and a link to log out. If not authorized, just show the text "You're not authorized" and a link to log in. Now, let's run to test. Open Blazor App 1. It shows not authorized now. And when I click Login, it redirects to the Identity Server. Then when I click Login, it will return me to Blazor App 1 with authorization. You can see it shows Hello here, but there is no identity name. We still need some config to get this information. Let's go to the config file. In API scopes, add user claims with name for scope 2. Then add the option Always include user claims in ID token. Then go to the program file. Add the option Get Claims from User Info Endpoint. Then map JSON key with claim types.name as name. Then set token validation parameters with name claim type. Now, let's run it again to test. Open Blazor App 1. Click Logout. Click the link to return to Blazor App 1. Log in again. The identity name is shown now. Great! Now let's implement the login function for Blazor App 2. You can see that many apps can use only one identity server to log in. Let's copy the config from Blazor App 1. Add the OpenID Connect package. Using the same library. Then change the cookie name. Client ID, and secret. Then, copy the login and logout APIs. Change the cookie name. Then copy the main layout to Blazor App 2. Now, run the app to test. Blazor App 1 is logged in now. Blazor App 2 is not logged in. Now when I click Login, it will redirect to Identity Server to check login, and it redirects back to Blazor App 2 immediately. It's authorized now. Then, when I refresh the page, it's still working fine. Then, when I log out in Blazor App 1 and refresh Blazor App 2, it automatically logs out. Next, we will configure to be able to log in with a Google account. On the hosting extension file, you can see the identity server has been configured to add authentication with Google, and we need to configure client ID and secret ID. We can click this link to register an account. If you already have a Google account, you will be redirected to this dashboard. Now, I will create a new project, set the name as Identity Server SSO, then click Create. Just wait a second for it to be created. Then I can select my new project. Then, go to the OAuth consent screen. Click Get Started. Input application name and your email. Click Next. Choose Audience as External, then Next. Input contact email. Click Next, then create this app. Once it is done, let's go back to APIs and Services. Go to Credentials. Click Create Credentials. Choose OAuth Client ID. Choose Application Type as Web App. On authorized redirect URLs, copy the link in Identity Server. Then click Create. When it is created, we can copy Client ID and Client Secret. Then run the app to test. Open Blazor App 1. Click Login. Choose Login by Google. Choose your account. Click Continue. It will redirect to our app with the name from Google account. Great. So we are done with authentication in SSO. Next, I will show you how to implement role-based authorization. Let's go to Seed Data file. For simplicity, I will change this and seed data again with some roles for these users. First, I will seed some roles to the role table. Get Role Manager from Service Provider. Define role names including admin and user. Then with each role, if the role does not exist, call Create Async to create the role. Then after user Alice is created, just call Add Role Async to add admin role for Alice user. If it is not success, throw exception. Then after user Bob is created, just add user role for Bob user. If it is not success, throw exception. Then go to Config file. Add new identity resource with name user info, display name extra user info, and list user claims including roles. On API scopes, add role to user claim for scope 2. The question here is why put in both identity resource and API scope. Identity resource is used for ID token. This is information that Identity Server returns to client. So in Blazor app, we can read ID token and get the role. API scope is used in access token, meaning that this role will be included in access token. When we use the token to call secure API, they can get the role from access token. Then on client, allow scope user info. Then we need to config Blazor app to be able to get this role. Let's go to Program File, Map JSON key for claim type role, Add token parameter role claim type, then add scope user info. Then in the home page, use Authorize View tag. With role admin, show the text, "This content for admin." If the role is user, show the text, "For user." Before running to test, we need to seed data again to create roles and attach roles to user Alice and Bob. Let's delete the database ASP-ID user DB. Set identity server as startup project. Then run update database. An empty database is created. Then go to launch settings, uncomment argument seed, rebuild to apply new setting, then run to seed the data. When data is seeded, the app will automatically stop. Let's comment argument seed. Set back startup project to app host. Then run this app to test. Go to Blazor 1, click Logout, then log in again. Great, it shows the text based on user role. Let's test with another account. Log in as Bob. It shows content for user role. So now you know how to do authorization with role-based in Blazor app. But how do we check the role if we need to call some secure API from Blazor app? I will show you now. On Secure API, create a new API controller, name it Demo Controller, set route as demo, define an HTTP GET with name secure, just return a text, "This content for admin." Then add Authorize attribute with role admin. Then go to Program. Open NuGet Package Manager. Search for bearer JWT. Install ASP.NET Core Authentication, JWT bearer. Then add Authentication. Then add JWT bearer with options. Authority is the URL of identity server. Set validate audience as false. Then add authorization. Then call use authentication. Next, on Blazor App 1, create API service, inject HTTP context accessor, and HTTP client factory. Create method get secure data async. On this method, get access token. Create client. Set base address to URL of secure API. Set authorization. Call an API to demo secure. Get text from content. Return status code and the text. Then in Home page, define a field API response. On initialized async, inject API service, call API service gets secure data async, then show the API response. Next, go to Program, add HTTP context accessor, add HTTP client, and add scope for API service. Then run this app to test. Open Blazor 1. Account Bob with role user does not have permission to access secure API, and it returns forbidden. When I log out, it shows unauthorized. Then when I log in with Alice account, the secure API checks the role and returns the text. Great. So now we know how to implement single sign-on system using Identity Server with authentication and role-based authorization in Blazor Web App. I hope this video helped you get a clear understanding of the process. If you found this video useful, don't forget to like, subscribe, and hit the notification bell so you won't miss future content. Also, if you have any questions or want to see more topics like this, drop a comment below. Thanks for watching, and I'll see you in the next one.